SNS College of Technology, Department of Artificial Intelligence and Data Science, Principles of Operating Systems. In this session, we will detail out the various terminologies adopted while a process is scheduled the CPU for its completion. Remember, these are the key issues that will allow an operating system to decide for optimizing the CPU utilization. So before we go with the various scheduling algorithms, we need to understand some terminologies that has been used during these scheduling criterias. CPU utilization. It is the percentage of time the CPU is busy executing processes, and the main goal of this is to maximize CPU utilization, and the operating system should keep this particular CPU as busy as possible. And if the CPU is idle too often, that means its system resources are wasted. The typical range of this particular type of utilization can be approximately 90% in a batch system and 100% in time sharing systems. The next one is the throughput. It is the number of processes which is completed per unit time, and the goal here is to maximize the throughput. The higher the throughput means more work is being done in less time. Scheduling algorithms that reduce the process waiting and execution delays improves the throughput. Turnaround time. The total time taken by a process from submission to completion, and it is calculated as turnaround time equals to completion time minus arrival time. And the goal here is to minimize the turnaround time, and it includes waiting time, execution time, and IO time. Shorter turnaround time means faster the job completion. Next is burst time. The total time a process needs a CPU to execute its instructions. That means, in very simple terms, it is the CPU running time required by a process excluding the waiting or IO time. The burst time includes CPU execution. Only burst time does not include waiting time, IO time, ready queue time. Next, waiting time. The total time a process spends waiting in the ready queue. It is calculated as the waiting time equal to turnaround time minus burst time, or for an FCFS, it is waiting time equals to start time minus arrival time. A waiting time does not include execution or IO time. The response time here is the time from submission of a request until the first response is produced, and it is calculated as the response time equals to first CPU allocation time minus arrival time. Goal here is to minimize the response time. And this criterion is especially important in an interactive and time sharing systems where an user can expect quick feedback. The response time is calculated as the first CPU start time minus arrival time in an FCFS system. It is the response time equals to waiting time. The fairness of the CPU getting the process execution is to ensure that every process gets a fair share of the CPU time, and the goal is to avoid a starvation. No process should wait indefinitely, and a fast scheduling ensures equal opportunity, especially important when priorities are being used. The next is predictability, where consistency in process execution time. Its goal is to minimize variation, and the predictable scheduling helps the users, applications estimate how long a process will take, which is very crucial in a real time system. Priority enforcement. Respecting the priority levels assigned to processes, and the goal is to ensure that the higher priority process gets the CPU execute themselves first. And many systems assign priorities based on the importance of the process which is there waiting in the ready queue. Scheduling algorithms must enforce these priorities without causing starvation for low priority tasks. So, here we saw the terms used to evaluate the way in which a process is scheduled to the CPU. The goal is to minimize the turnaround time, waiting time, response time, thereby maximizing throughput and CPU utilization, and also how a process waiting in the ready queue can be avoided from starvation. Thank you.